Hello, here Abdul Asif performing the practical, and our objective is to find the band gap of a reverse biased PN junction. What is the apparatus? I am showing you the apparatus. Regulated DC power supply. We have two meters on it, voltmeter and ammeter, to measure voltage and current respectively. We have an additional current meter, microammeter. We have a soldering iron. We have a digital temperature measuring device, digital thermometer. We have a conventional thermometer. We have a metallic stand, and a bunch of wires going in the power supply, in the meters. So what is this regulated power supply, DC power supply? One thing I want to make you know, that let me turn on the device. Now I am going to change the voltage from minimum to maximum. I am rotating the rotator, and you can see the change on the voltmeter going on this scale. So the voltage is changing, and we have a maximum voltage up to 60 volts. It's ended. Now we are decreasing voltage. Voltage is decreasing perpendicular as the rotator moves. It's a perfect rotator. Where it goes. Oh. Now we have a ammeter device to measure the current, but notice what happens. We are rotating the rotator from minimum to maximum. It is some art, but just it's finished. But no change on ammeter. We are seeing no change on ammeter. Now we are decreasing current. No change on ammeter. It's unfunctional. We have only a voltmeter working on this regulated DC power supply. Positive terminal, this positive terminal connected to the microammeter and additional current measuring device. So I think that's why our default ammeter device in DC power supply is not working, because we have set an additional current measuring device, microammeter, to the regulated DC power supply. Positive terminal wire coming from the regulator power DC supply is connected to the positive terminal of the ammeter. Now we have a other terminal, whether it has a negative sign or no, it has no negative sign, it is blank. Now the second wire, this wire is going, where it is going, the second wire is going to the metallic rod, this metallic rod, and then this wire from the metallic rod is going to the regulated DC power supply and connected to the negative terminal. Now understand what is happening here. There is nothing much difficult. Positive terminal connected to the positive terminal of the microammeter, and this is a connection between microammeter and the metallic rod. It is a connection. Now this is a negative terminal of regulated DC power supply. So this wire is making connection between the positive and negative terminals. The charge is coming through the positive terminal, and we measure it in this microammeter, Then the charge pass through this wire, second pole, and the charge pass to the metallic stand, and then from there it goes to the negative terminal. The current cycle, as you know, is going on here, and we can measure it because it is passing through this meter, and we can measure it not in amperes but in micro amperes, much smaller unit, so smaller chances of error. Now we have a thermometer, conventional thermometer. What is its room temperature? Let me see. Oh, my camera is not showing that red line. That's difficult to show you. You can see in the bottom this red line. Yeah, this is going to the 33 degree centigrade. So this is our room temperature, 33 degree centigrade. This thermometer has been put in this metallic rod stand. So when the charge coming from this DC power supply positive terminal came to the microammeter and then passed through this wire to the metallic rod, so obviously when the charge enter in the metallic rod's temperature get increased. It will produce thermal energy in this metallic strand, and then the charge pass again to the negative terminal of the DC voltage supply. So the heat produced or the increase in temperature at this metallic rod, we can measure it through this conventional thermometer. But stop here. What is this? This is soldering iron, and it gets heated when the power supply gets on. Now see what is happening here. Soldering iron is connected to the digital thermometer. So this digital thermometer will show you the heat temperature, increase in temperature when the soldering iron gets heated. It will increase in temperature, and this digital thermometer will show you the increase in temperature of the soldering iron. Soldering iron is directly connected to the power supply, not with this DC regulated supply. So when we give it supply, it gets heated, its temperature increases, and we can see that temperature on this digital thermometer in degrees centigrade. So now what you understood? You understood that the charge passing through the DC voltage, DC regulated power supply through the microammeter heat up this metallic strand, and we can measure the increase in temperature due to the heat up in this conventional thermometer. And we get if we supply power to the soldering iron, it will also increase its temperature, and we can see the temperature with this digital thermometer, and it is connected to the soldering iron. So when the soldering iron gets heated up, its temperature, we put it in this metallic stand, so we can measure the current increase in temperature due to the soldering iron and due to the charge passing through the DC voltage. So here the practical is about the band gap, but the procedure we have followed is the procedure involving temperature meters, the calculation of the temperature. So in that manner we can say that how much charge is heating up how much particles in this metallic stand. So that's the concept.